In this video, I'm going to explain to you how to use ratios and proportions to solve problems using three different methods. Method one, we're going to use a bar model method. So I'm going to write that right there, a bar model. Okay, with a bar model, you need a straight line up and down. Talk about where you start, because there's always a starting point. It says Mason and Laney ran laps to train for the long distance running team. The ratio of the number of laps Mason ran to the number of laps Laney ran was 2 to 3. Ratios are always talked about in order. So once you see the word the ratio of, it's going to start giving you the first person. Mason ran, so the first person is going to be Mason. I'm going to put an M here. To the number of laps Laney ran, I'm going to put an L here for Laney. Mason had 2 blocks, so we're going to write a bar worth 2 blocks. Now these bars have to be the same exact size. So Laney has to have 3. So I'm going to make that a little longer. Make sure these pieces are the same size, because ratios are a comparison of numbers that actually have the same size pieces. So there's a total of 5 pieces here. Okay. Let's answer the question here. So in part A, it says, if Mason ran 4 miles, how far did Laney run? So in this method, it says that Mason ran 4 miles. And those 4 miles are actually over 2 blocks. So 4 divided by 2 is 2. Each of these blocks is worth, in this problem, 2 miles. And that goes for both Laney and Mason. Because the blocks are the same size, once you find one of them, you'll know all of them. So it asks, how far did Laney run? Well, we know that Mason ran 4 miles because, 2 times 2, or they gave it to us. And Laney is going to be 3 times 2, or 6. So Laney ran 6 miles. So for this question, no matter what you do, Laney ran 6 miles. That's going to be the answer for this problem and the next 2 that I'm going to show you. Okay, so method 2, you could use a ratio method. Okay, just take it right off of the paper. They give it to you. So 2, 2, 3. And it would be for M for Mason and L for Laney. It's very important that you label. You don't have to write the whole name, but I would write something. Okay. That said, Mason ran 2 laps in 3 laps. Okay. So it's 2 whatevers to 3 whatevers. It doesn't really matter. So if Mason ran 4 miles, so Mason, how far did Laney go? Again, the answer is going to be 6, but why? What's the scale factor from 2 to 4? What's this value? It would be multiplying by 2. Same thing with this one. 3 times 2 is 6. Okay, you don't want to leave the number right there. You need to say, again, Laney ran 6 miles. And the last method, you're pretty familiar with it. I call it a fractional method. Okay, a fractional method. And I don't want to use the really word of fraction. I want to use the word ratio. I don't know, I wrote an M there. Ratios and fractions are a little different. We'll get into that a little bit better. So it was between Mason and Laney. So in a fraction, I'm going to put Mason on top and Laney on the bottom. A ratio is a comparison between 2 numbers that could be parts or wholes or whatever. That in a fraction is really a relationship between a part and a whole. That's really the difference if you're wondering, but I'm not going to get into detail about it. So if Mason ran 2 laps and Laney ran 3 laps, what I need to do here is be consistent with this proportion. And this is going to be pushed for the next few years, and actually for the rest of your math life. When you write a ratio or you write a fraction, you need to make sure that you're consistent across that ratio or fraction. So no matter what goes on top, that's going to be Mason's problem, and anything on the bottom is going to anything belongs to Laney. All right, and then this problem, it says that Mason ran 4 miles, so 4 goes there, and then Laney, well, we'd have to find that out. So 2 times 2 is 4. You do the same thing to the bottom, is 6. All right, so we don't want to, again, leave that answer there. You need to write your answer like that. Laney ran 6 miles. Do not leave it in the fraction. You're going to get something wrong. Okay, so what you would do here is, let's see how you would maybe do this. Okay, if Laney ran 930 meters, how far did Mason run? So just working backwards here, if I did the fraction, Mason, Laney, Mason went 2 laps, Laney went 3 laps. What did they give us here? They gave us something that Laney did. So where's that going to go? Well, that's going to go where Laney's problem is. It's down here. Okay, how do I get from there to there? Well, you can divide, which is 310. So times 310 on the bottom times 310 on the top, and you get 620. So what was the question asking? How far did Mason run? Mason ran 620, what? Not miles, it says meters right there. So meters. So this is the answer that I'm going to show you right there. So for this one, ratio method, Mason to Laney, 2 to 3. Laney ran 930, so Laney 930. Okay. We found out that the scale factor was 310 times 310. So if we do the same thing to that side, okay, it's 620. So again, Mason ran 620 miles. And last but not least, if you did Mason and Laney, again, you have 2 blocks. Laney's going to have 3 blocks here. And it says that Laney ran 930 miles. And this is where you're going to actually divide by 3, right? And if you go 930 divided by 3, you get 310 like we did before. Each of these is worth 310. 310. Okay, that's called the constant of proportionality. This is what that's called. And so it says, how far did Mason run? Well, there's 2 310s. So 310 times 2 is 620. And again, it's meters. Okay, I hope you enjoyed this video. If you have any questions, please do not hesitate to contact Mrs. Hogestein or myself, Mr. Brown, and I'll talk to you next time. Thank you.